Hello, my name is Nathan, and today I'm going to be taking you through the very last part of practice midterm number 2 for physics 457. So for this question, we're given two different capacitors here, capacitor 1 and capacitor 2, and these capacitors are discharging along these wires. So we've got one wire here, one wire here. So for part A, we're asked, what is the direction of the force on the wire in capacitor 1 from the wire in capacitor 2 due to the discharge? And the way we're going to figure that out is by using our right-hand rule. So the current is flowing up here, so my thumb is going to point up, and my fingers are going to curl around, meaning that on the negative x side here, we're going to find that it's pointing towards me. The magnetic field is pointing towards me. That's going to transfer to over here. So the magnetic field is still going to be pointing towards me at capacitor 1. And then we need to apply the right-hand rule again. So the field is going to be pointing towards me. So the way I use the right-hand rule for this one is my fingers point towards me in the direction of the field. My thumb is pointing in the direction of the current flow. And so the force is going to be pushing down. So for this one here with the magnetic field towards me, I'm going to find that the force is pushing down, and that's part A. So for part B of question 4 on the physics practice midterm, we're going to do the exact same thing because it asks us what is the direction of the force on the wire in capacitor 2 from capacitor 1. So again, the current is flowing in the positive x direction here from capacitor 1. So right-hand rule, thumb is pointing in the direction of the current, fingers curling towards me. That means on the top here, we're going to get the magnetic field pointing towards me again. So over here, it's also going to be pointing towards me because it's on the same side of the wire. For this one then, my fingers will point towards me, same direction as the magnetic field. The thumb is going to point in the direction of the current flow. So you get this really awkward position where the force is actually going to be in the plus x direction. So it's going to be going to the right here, and that's force for F, and that is part B. And I'm just going to jump straight into part C here. So part C asks, what does this tell us about the divergence of the Maxwell stress tensor? And explain how you know. So the divergence of the Maxwell stress tensor is the divergence times our tensor. We also know this from class to be equal to negative, dg over dt, where g is a vector. And so this is representing the change in the momentum field. So we know that F1 is pointing in the negative y direction, and F2 is pointing in the positive x direction. Therefore, the momentum must be coming from the fields because these two are not in the same direction, and conservation of momentum can only happen in the one dimension here. So the momentum must come from the fields, and to conserve momentum, it follows that the momentum must come from the fields. So this here, our divergence of the Maxwell stress tensor, must be non-zero. And in fact, it must point in the negative x hat and the positive y hat directions so that we get something counteracting this and something counteracting this. And that's part C of question 4. Thank you for listening, and that's the practice midterm, and good luck.